Hi Nigel, this is Alexander Sims, student number 10402796. Before I get started and dive into my main program, I just wanted to brush on a problem that I've been having. Basically, an older version of my program, the translation sort of worked, the scale didn't work, but the focal did. I just wanted to sort of show this, and I'll submit it with the submission as well, because it demonstrates that it worked at some point, but down the line it's somehow seems to have broken, and I'm not sure why. Order of multiplication is fine, but things seem to be going wrong, so I just wanted to cover that base before I moved on. So I'll submit this version too. Basically here, let me start from the highest level. I sort of tried to engineer this quite cleanly as well. So we come into the window code, and we just have a dictionary which contains information that gets passed to the renderer. Here we send in our translation values and everything that we want to sort of multiply the matrices by. We have a couple of draw calls. Here we have some default values for setting a default origin scale factor for the models that are different sizes. And then we have this canvas call, which actually invokes the renderer and tells it to draw a new frame. Down here it just handles any GUI events that happen to call this this paint method here. Next, I wrote my own matrix library with maths. I use C#'s operator overloading, so I can do stuff like just use the asterisk to multiply two matrices together. Also, just some default constructors here of different types. We have some initialization methods, and then we have our methods to create the matrices that we need to work with. I derived these ones from your code, but I obviously implemented it with my own structure. And then I did the rotation matrices myself. Also have a method here to convert it to radians, because this, it takes an input of degrees, so we want to get it in radians so we can do the transformation properly. And then we do a final method, which is the public interface, which will rotate by all of the current planes, so you don't call these all separately. That's about it for that class. We then have a vector class, and this is a homogeneous point. It represents a homogeneous point, or just a standard vector 4. We also have a face class that extends that, but for now this just contains any of the sort of operator overload math that we need to do, any extra math that we need to do, such as normalization, and finding out the cross products and actually transforming it and rescaling it back to a normalized point. So this is all fairly straightforward. It extends on from the code you provided. It's not a direct sort of rip of it, but it does incorporate some components you added. Then I have a face class which extends, so it doesn't actually extend, I thought it did, but it implements the vector 4. Here we have a collection of 3 vector 4s to represent a triangle, or a face, sorry. And then this just handles, this method here is pretty important. It computes the face normals by getting the dot product between 2 vectors and then normalizing it. And by doing that, we can then get a sort of scalar value for each x, y, z component, which represents the normalized factor. And then we can do backface culling with that in order to get rid of any hidden surface that we don't need on the model. A couple of helper methods here, so I was just finding the center origin of the face, as well as the transform method, which I believe you actually provided, and I pretty much just ripped this myself, but modified it so it didn't run off the quad like yours did. I never got round to implementing my light class completely. I struggled with some of the earlier concepts, and it pushed me back with that email that I sent you, and I ended up doing the OpenCV part because I was running out of time. I then have a mesh class. The mesh class does pretty much what you think it would do. You initialize some buffers here, so they're your vertex and index buffers. Then we fill the vertex buffers with all of the indices and vertices. And then we create a geometry buffer which has all of the faces in it, and that gets passed to the renderer to draw the mesh to the screen. This model struct, I can extend it to add more models as we sort of got them, and that's read in from the UI and updates the current model that we're working with. And last but not least, we actually have the renderer class where all the sort of magic happens. In here, we have like a public interface where you set the mesh data from the window every time that something changes on the draw event. The world info again is that dictionary I told you about earlier. We have a render mesh call. I was going to multi-thread this because I realised that the T-Rexes were slow, so what I was going to do is divide the mesh into several subsets and fire 4 threads off at once to draw to the context, but I decided that I was sort of running out of time and needed to prioritise my final year project. But here we create the graphics context and then we start drawing to it in this draw point method. Now this method's slightly longer. We compute our normals in here, and then but only if we've set the toggle to do so. And that was going to be used for the Phong shader, but I never got around to implementing that, and I figured as I've already got OpenCV done, I didn't need to do the Phong part as well. But this still gets the normals for the faces, and then after we get those normals, I can do backface culling by checking if the value isn't greater than 0, because if it's not, then we can assume it's not as close to the viewer as we want, and therefore we don't need it. However, this has, as you said in the brief, it does sometimes get confused and removes faces that should be present in the viewer. But I think if I spent some more time, I could probably fix that by using some of the algorithms. And then we come down here, and it was just basically the color poly method, but instead of filling it with a block color, I wanted to get a random color based on the normal, so you get like a rainbow tiger, which is a bit strange, but yeah, we do that. Finally down here we have the transform mesh method, which gets the transformation matrix by multiplying the translation, scale, and perspective and rotation together. This is where it's not working. I'm not sure why it's not working. It was working before I put rotation in. I took rotation out and it was still broken. So something's gone wrong. I've not been able to debug it, and the deadlines unfortunately come up. So I'm just having to submit it in this state. So hopefully that's understandable. But yeah, we transform every face by the transformation matrix. So now let me run this. I'll give you a brief sort of overview of how it works. First of all, when you open up, click on tiger or whatever mesh you want. You see it's looking up his arse at the moment. So we can toggle show points to draw the mesh. And as you see at the moment, he's got a lot of unnecessary lines drawn. So if we toggle surface removal, you can see that is reduced quite significantly. As I said, translate and focal aren't working anymore. I don't know why. Maybe you'll be able to point something out and I'll kick myself. But as you can see, rotation works nicely. You can pivot him on his y-axis, on his x-axis, and on his z-axis. And you can also toggle the polycolor color. And here's your. It's quite. Oh god. It's quite strange. And if you notice here, this sometimes happens. You do a force redraw, and it will just draw the mesh back to the screen. Then you have a teapot, and if we don't have surface removal on and we turn the polycolor off, it draws correctly. We can rotate that up properly. And toggle surface removal, and you see my surface removal is getting confused. So this really was just a short demonstration to show you that it does work. Surface removal works to a certain extent, and you can rotate on the axes. I'm quite disappointed that I didn't get it to be as finished as I'd have liked it to, but like I said, I've run out of time, and this is the sort of best I can do for now. So hopefully that's okay. Thanks for watching.